Thank you, Robin. Greetings from Washington, D.C., where there is no insurgency taking place today, thank goodness. Yes, I'm going to talk about blockchain, which is a nice segue from what Nigel was talking about in terms of where a lot of innovation is happening in cybersecurity. And I might offer that perhaps there's a little bit too much innovation going on in blockchain. Companies are trying to use blockchain for pretty much everything. There's a lot of good stuff going on, but there's also some applications that might be better accomplished by other technology. I was eager to hear Nigel trot out his American accent. I don't think he has a better one than I do. And then I could counter with my British accent, which is a combination of the royal family, Cockney, Irish, Scottish, and probably Aussie too. I'm not too good at accents. So here's just a little bit about me, and I'm not going to dwell on this. I've done a lot of research on blockchain and a lot of other things, and in the interest of time, I'm just going to move ahead. Is blockchain the best thing since sliced bread, or is it money down the toilet? Some people have called blockchain bigger than the internet. It's bigger than the Iron Age, the Renaissance. It's bigger than the Industrial Revolution. Here, from all those really outlandish comparisons, I just pulled out a painting by Giotto. So is a line of code or a paper more influential than 250 years of artistic blooming, or 100 years of mechanization of society? I'll leave that to you to decide by the end of this presentation. So here you have the other side, but there's the expected whiplash. Blockchain is one of the most overhyped technologies ever. So you've got fans on both sides, or you have fans for, and you've got detractors. And I did 4 months of research on blockchain and applications. And I talked to probably 100 practitioners, academics, technologists, thought leaders, and they were pretty much split 50-50 on people who were really excited about it and people who were over it. So I'm not going to talk that much about blockchain basics. You all know that blockchain underlies the process used to mine cryptocurrencies, and it's very, very good at that. The question is it good at anything else? A little bit more about what blockchain is. It's just a ledger, like the piece of paper you see on the right, for documenting transactions, but it does it electronically, and it's a super ledger. It's supposedly immutable, promises to be decentralized, secure, irreversible, distributed, and anonymous. So all these great things that we want for security and privacy and to verify the legitimacy of transactions. The problem is, in a perfect world, it would be all these things, but we're not in a perfect world. So in a sense, yes, these are all accurate, but in another sense, it's not so. Whoops, let me just go back. So this is how blockchain works. In a public blockchain, which is like Bitcoin and Ethereum, there's no central authority. If you want to conduct a transaction, it gets crowdsourced, and people perform math puzzles. They do computations on their computer to get the right to verify a transaction. If they do that, they get rewarded. The reward mechanism is a Bitcoin or whatever, Ethereum coin, so they get a reward to do this. But it takes a lot of processing power. There are people who have basements full of computers doing these things, running 24 hours a day. And I'm not sure that the Bitcoin that they make equals the amount of energy they expend. They have tremendously high electric bills and generate a lot of heat in the basement as well. So when a transaction is verified, it's stored with others in a block, and then subsequent transactions are stored in new blocks. And then each succeeding block connects with one prior block via a unique digital signature. But if you attempt to alter a transaction, it unlinks the block and it forces what is called a fork. So the people who do blockchain have to stop that line and then fork it over to a whole different following line of blocks to be added. And here are the blockchain types. The ones I was talking about with the mechanisms, and I was talking about a proof of work mechanism to get rewarded for performing these computations. That's part of the public blockchain. As I mentioned, it's an energy hog, and it puts trust in the technology. It's sort of a black box. You don't have to worry about individuals generally tilting the scales or putting a thumb on the scales. Private blockchain types, which are another valid type, do away with the decentralized beauty of the public blockchain, and somebody runs it. So someone's at the door saying, you can come in, you can't, I know who you are. So it takes that trust away and puts it in an authority to be a person, a company, or an organization. There are benefits to that, which include it's more scalable, energy efficient. Then there's hybrid, which puts a private network on a public blockchain, and you sort of get the best of all possible worlds there, but it gets a little complicated. And you have a consortium, which is really a private one that's run by a group. And the IBM Food Trust is one such example. And one of the issues with that is it may run into antitrust issues if everyone is in the same industry. My problem with blockchain, and I'm a fan of blockchain, is that companies are coming and trying to put it into every possible use. It's like the boy with the hammer. He sees a nail and everything, he's holding a hammer, everything he sees is a nail. So with blockchain, everything is seen by some people as a solution or an application for blockchain. My argument is that we shouldn't abandon fundamental security principles to always fit the technology to the application and not the application to technology. And there are simpler, easier methods sometimes than blockchain. And that might be distributed ledgers, of which blockchain is one type. It could be cloud storage, could be centralized databases. There are lots of use cases, test cases in blockchain. The problem is finding a case that actually develops into a full-fledged lasting application. So you see examples here of pharmaceuticals. It works well for supply chain security. It validates authenticity. It facilitates the provenance, so you can see where it actually came from, and make sure that custody isn't broken, data privacy. So there are a lot of great applications, but there aren't many that have been put into general use. Excuse me for that. The few we have are cryptocurrency. The IBM Food Trust is doing pretty well. And there are some government initiatives. In the United Arab Emirates, they've rolled out paperless smart Dubai. Spain has a paperless port of Valencia. And Brazil has put bidding on government contracts on the blockchain. There are a lot of other examples of that, but these are kind of niche. It's not like the whole government is switching to blockchain. They're doing it in small doses. I want to spend most of my time on the security applications of blockchain because these don't get a lot of attention. Most of it goes to cryptocurrencies and storage of value. So here are the 8 security applications that I've studied, and I will go through each. Okay, so first you have identity management. And identity management, I think, is the most promising, or one of the most promising applications in security for blockchain. One of the latest forecasts by a marketing company that looks at security investment projects that the market for blockchain and identity management is going to grow from $356 million worldwide last year to $21.8 billion in 2027. That's a compound annual growth rate of 80%, which is enormous. And I'm not sure, again, whether that's just people getting caught up in the hype or those are real applications, but there are people putting money behind that. And so you you always got to see where the money is going before you dismiss it. With identity management, there's a lot of applications. You might have travelers, and using a permission blockchain, it would limit organizations such as airlines and immigrations and customs officials um, to access only information necessary for them. Uh, Governments are using blockchain to verify the identities of refugees. That's happening in Finland, where they're providing asylum seekers with prepaid debit cards that links the cards with the refugees' identities via blockchain. The there are some issues with identity management. Um, Ethereum allows users to create digital identities via decentralized identifiers, identity management, and embedded encryption. And there are 33 startups at least that sell blockchain solutions. So there's a lot of noise out there. One of the ones that I thought was interesting was VID, which helps prevent document fraud. There's also Object Tech, which enables individuals to obtain digital visas. I know Jeff is on this call, and he's one of our hosts. And when I talked to him, he showed some skepticism, which I respect. He said, "quote I've yet to see a startup or a technology that brings a digital value proposition into a real world security context." And he worries about using blockchain for personal identity from a privacy point of view, and that trust in the application might outstrip its ability to provide value. So moving on to check my time here. Okay, I'm good. Moving on to access control. A lot of companies have been experimenting with using blockchain for both physical and logical systems. The issue here is that we already have pretty good access control systems, and blockchain isn't necessarily improving things. There's also scalability and agility concerns. In January 2019, a research team from the University of Saskatchewan issued a paper documenting their test of an access control application based on Hyperledger. And they found that blockchain is an improvement for storing and managing the software layer of physical access control. And a lot of others are high on it too. There are use cases to use blockchain with permissions for logical and physical access. You could add sensors and inputs for location management, geolocation, and multi-factor authentication to verify someone's permission to be in a certain location at a certain time. Using artificial intelligence and security configuration management tools could create an integrated access control system that would learn and identify relationships between people and, say you're in a warehouse, between the warehouse and shipping processes. And access transactions in the database would be stored securely and would leave a really, really good audit trail. The problem is, again, as I say, there hasn't been a macro application that is better than what we've already seen. Moving on to the Internet of Things. We all know what the Internet of Things is. Enable smart devices to exchange messages, make orders, complete transactions. And now there are multiple Internets of Things. There's industrial Internet of Things and consumer Internet of Things, and probably ones that were just created as I'm speaking. The key to effective functioning of IoT and the IoT is the transfer of tremendous amounts of data in almost real time. And that, of course, requires edge devices over centralized databases. It could be that blockchain is an effective way of confirming that an IoT sensor records reliable specific data from, say, a power plant. If AI is used, blockchain might be able to solve the issue of AI, which is information goes into a black box, and then nobody knows the how the result comes out of that black box. It's like a jury. You go in there and you put in you throw information in there, it comes out, and the decision and you're not quite sure how it was made. So this, even though that wouldn't help knowing what's in the black box, if you can confirm that the data came into the system via the blockchain, if AI receives data from IoT sensors that are secured on a blockchain, then you have better confirmation and verification of the application. Internet of Things is being used by the U.S. Air Force and more recently by the U.S. Space Force. A contractor has been awarded a contract to protect the physical devices used by the Air Force and the Space Force, everywhere from server room, and in the case of the Air Force, to the battlefield. One of the issues with the Internet of Things, as it says here, crypto means latency issues. So the IoT relies on the movement of massive amounts of data in real time. Strong cryptographic processes introduce latency, and the latencies are not acceptable in near time and real time service situations. So blockchain may not be best suited to record raw data at the source. Now moving on to smart contracts. Smart contracts are the one area where I think blockchain outside of cryptocurrencies has been pretty successful. It's an exchange of computer code between parties that runs on top of a blockchain, and it's really it memorializes an agreement. But it's only really good for virtual agreements because it, at the same time that it provides remuneration or consideration where it pays off the contract. It pays off the contract when certain code is activated. So you do something, in the blockchain. You do something. You enter a line of code, say, and that's what you have to do to satisfy your smart contract, and then you get paid. Problem is when you get to the real world, it's not so easy. With smart contracts, when it's virtual, the encryption is both the compensation and the product. By fulfilling a smart contract, an individual automatically gets paid. So that it links fulfillment and payment. In the real world, in the physical world, that doesn't happen. There's an extra step, and it doesn't prove that the terms of the contract were fulfilled. So you don't know if something was actually done in the physical world. However, for all online and all virtual contracts, it's been pretty good. There are some detractors. One gentleman I was talking to, who's the CEO of the Blockchain of Things, said that it's neither smart nor a contract. And he noted a litany of problems, including what recourse you have if you're not paid. But generally, it's been accepted that smart contracts have been a success story. Just checking on my time. Video is one of the ones that hasn't been moving forward too robustly. It's very experimental. It's a great application to verify the video integrity and chain of custody, especially when you're dealing with deep fakes. And we all know that deep fakes have become a tremendous problem. And there are so many sources of video out there. Can you put a hashtag algorithm to verify that a video is changed? That's a possibility. There are companies that are doing that. The Pentagon's Defense Advanced Research Project Agency is working on that. It's something called the Metaphor platform. So it hasn't gone very far yet, but it's, there's hope out there. Private messaging. I'm not going to spend too much time on private messaging, sort of running up against my time here. It's working pretty well. And the data is held in nodes. It's harder to intercept. So that's a fairly robust application. The domain name system, it's, the domain name system, of course, there are efforts to decentralize it, and that's a Handshake, which is an Ethereum protocol that uses its own coin for name registration, and Blockstack, which is based on Bitcoin, as well as the Ethereum name service. So those efforts are proceeding. They're coming pretty well. Data storage, distributed storage is taking on cloud storage. Cloud storage often has a single point of access, where data storage on blockchain, it's spread all over the place. It prepares data for storage by creating data shards or segments and encrypting the shards, and it generates a unique hash for each of those shards, and it creates redundant copies of each of those shards. They're then distributed across the nodes of the blockchain, and the transactions are recorded in the blockchain ledger. The system validates and synchronizes the transactions across nodes in the blockchain. The problem with this one is that it's incredibly expensive right now. Someone I talked to said that to store a single 1 megabyte insurance policy in one of these systems would cost $750. That's for 1 megabyte, and it would take 14 minutes to save it. So that's not really viable at this point. Just to quickly wrap this up, I'm coming to the end of my time. The biggest benefit and the biggest challenge of blockchain is the same thing. It's trust. Who are you going to trust? You're going to trust the technology, or you're going to trust the people? And that's really where the divide is. There are people who say, no, it's like, we don't want people in there. That people are the problem. Just let the technology do it. However, the technology can be manipulated, especially through the APIs. Blockchain is very strong, but the cryptography will get old, and people will figure out how to get into the blockchain through APIs. Other people say, okay, let's trust in humans. So the real question is, which side do you fall on? At least that's the case right now. Here are some other challenges. As I mentioned, APIs, aging encryption, people can manipulate private blockchains, the power use that I talked about. And really, the sum of it is like, don't use blockchain if you have better, cheaper, more effective alternatives just for the sake of using blockchain. And here are some, if you're interested in using and you want to sort of go through a decision tree, I can leave this with you. I hope folks here will make this available for download afterwards. And this is sort of a good way to see, okay, do I have an application that's right for blockchain? And I'm not going to be able to, unfortunately, participate in the panel in a half an hour. I got mixed up with the time zones. In the United States, we went to daylight savings time a few days ago, and there's apparently 1 week in the year when daylight savings time occurs here before it happens in the UK. And so I actually have another presentation I have to make at the time of the panel. So I regret that. But if there are any questions, I'm happy to take them. I'm not sure, Robin, maybe you could pose them.
Sure. Yeah, thanks, Mike. And Mike Beck's following, but Mike, if I could just delay you for Mike Beck for a couple of minutes. Maybe there was a couple of questions that came in, Mike, which if we could just handle quite quickly, then let's try and do that then without delaying matters too much this afternoon. So a question from Pete Jones. Do marketing departments get too excited about blockchain as a term as opposed to understanding its application and benefits? And part of that question, I think, is equally as applicable to any other security technology. But with blockchain in mind, does that?
Yeah, they definitely do. It's a cure-all. It's when someone says it's bigger than the internet, it's bigger than the Industrial Revolution, it's kind of hard not to get onto that bandwagon. But if you don't know if you don't know coding and you don't know cybersecurity, chances are you don't really understand the technology behind it. It's on the face of it, it's not that difficult, but when you start getting into the mining and then really on questions of trust, people sort of overlook that. Yes, it's something they hear blockchain, we got to do this. And it's not just marketing departments, it's CEOs, it's executives who think this is the next thing. And it's startup companies that are jumping on this, and some of them do well. I bet most of them fade away though, because they're seeking out, better mousetraps when the best mousetrap may already be in existence.
Yeah. Thanks, Mike. I think that resonates in so many areas. And one from Jeff, in actual fact, suggesting when you were chatting about blockchain about a year ago, there was a question around whether the future power of decryption technologies meant that we could see the immutable element of blockchains being broken. So to that extent, has anyone yet determined a method to update the encryption of a blockchain, especially a public one?
They're working on it. That's a great question, and that's something that people are looking into the security of blockchain and are taking very seriously, especially with quantum computing maybe around the corner, where all those things, it's a completely new game when you're not doing ones and zeros, and it becomes just the possibility of one and the possibility of zeros. Old computing paradigm gets thrown out the window, and every cryptographic process and algorithm is obsolete. So yes, they're working on it, but there are so many sort of different concerns and things happening at the same time that it's very much in the air. But it's a great question.
Yeah, brilliant. I think there was another one other question I've spotted. Well, if we've got one more minute, I feel that people see blockchain as being secure because of the 51% node consensus idea being solid and foolproof. But isn't there a possibility that a very large entity, Chinese government perhaps, if we just pick a random example, could sponsor a subversion of it to just bring it down?
Well, there are different blockchains. So with Bitcoin, probably not going to happen because there's so many participants in it. But with smaller blockchains or newer blockchains, I think it already happened with Ethereum. That's 51% attacks. That person is exactly right. 51% attacks have happened. Luckily, they were with smaller blockchains, and the consequences weren't devastating. But the proof of concept, it's happened in the real world. And yes, absolutely. And that's one of the arguments for a permission blockchain. So who's in, it's like, oh, I want my friend, I want that person, but not that person or that company. Again, you pick your poison there. They both have positives and negatives, but that's a great point.
Well, thank you, Mike.